6, we're doing systems and linear equations. We spent a whole week on graphing, and graphing was like tormented you forever, right?
Yeah.
Until I told you could use a calculator, and then you're like, ooh, calculator, fun. But graphing it's a lot of work. It takes a lot of time, unless I give you a calculator, right?
Yeah.
So it's usually an estimate what the answer is, and so it's not always the best thing to do. So I like to be efficient. I think most people in general like to be efficient in what they're doing. So we're going to work on that. So you don't need to write this down. This is just one of those intro things we need to think about. So if I ask you what the solution of this is, you would look for the intersection, correct?
Yeah.
Where they're equal. Okay, well I start going over here and I'm a little more than 2, not 2.5, I don't know, not 3.5. And then I'm almost 5, but not 4.5, but that's like horrible, right?
Yeah.
Okay, so we need to have an algebraic way. Now obviously we're going to get fractions, but wouldn't it be easier to get a fraction algebraically than estimating it on a graph? Yes. Okay, so we're going to work on that today. First of all, we're going to talk about just a little bit of vocabulary. A system of linear equations is a set of 2 or more equations using the same variables. And it's 2 or more, so you could have up to 20. Just all the variables are to the first power. There's no squared or anything like that in these, because they're linear. And it says use this, and then, the solution of a system of linear equations is a set of ordered coordinates, x, y's, right? Or x, y's, and z's, or whatever, that simultaneously make the equations true. So it makes all the equations true at one time. Wasn't that the intersection? Okay. So with 2, it was pretty easy. You can get 3 and 4 and even more. Okay, so there are 3 possible outcomes when we find a system of linear equations. We could have one solution where they intersect one time. We can have no solutions where they never intersect at all. Or we could have infinitely many solutions when they're all the same what? Same line when I graph them. Because if they all land on top of each other, they're going to touch infinitely many points, or touch at infinitely many points. You guys remember seeing this in Algebra 1, kind of?
No.
A little bit?
No.
Okay, well we should be reviewing Algebra 1 today, so hopefully it will start coming to light a little bit. The only time 2 lines are not going to have a solution is when those 2 lines are what to each other?
Parallel.
Parallel. And parallel means they have the same what?
Slope.
Good job. So in that y equals mx plus b, it would be the m. And usually what happens is you don't notice it because one, you could like divide it by 4 or something, and it would come out to be what the other one is. So
Did you tell me to write those down?
you need to know that there can be one solution, no solutions, or infinitely many solutions. I don't know. Not too much of a picture, right? But big thing to know is if there is no solution, the lines are what to each other? Parallel. And if there's infinitely many solutions, they are on top of each other. Okay? So when we solve it algebraically and we come out with infinitely many solutions, you may have a 6 equals 6 or something like that. Does 6 equal 6 all the time?
Yeah.
Yes. So that would be something that would be infinitely many. When we solve it algebraically for no solutions, you might get 6 equals 8. Does 6 equal 8?
No.
No. So that would be no solution. Without a variable, I can't make 6 equal 8, can I? Usually it's 0 equals something, but it could be 6 equals something. No, don't. Put a 0, don't put a 6 for that example. Sorry. Because leading up to the next thing, I want you to know that it comes out to be 0 when we're doing the next process that will be new completely.
Why wouldn't you have to change to the 6 on that?
No, because I mean this other side could come out to be 0, 0, 7. Oh, here?
Here. Isn't that a 6?
No, this is a 0 doesn't equal 8.
That's a B. I thought that was a
Oh, that's a B. Y equals M plus B. Okay, you guys good?
Not quite.
So for the infinitely many solutions, that's just where your solution there would just be whatever number.
Yeah,
Next.
like it would be 7 equals 7 or 6 equals 6 or 0 equals 0. It would equal the same.
X, right?
No, you wouldn't have a variable with it. Okay, so we have a system of equations. We have the x plus 2y equals 3 and x minus 2y equals 4. If I ask you to solve this system, what would you do?
Stare at it for a little while.
Stare at it for a little while.
Was
Figure
equals
out
mx plus b.
Anybody like thinking towards elimination, substitution?
You could put something in front.
You could put, we're not gonna guess each other.
Would you eliminate the x's because they're both the same?
Yeah, but look at the 2's. I got positive 2 and negative 2. Why don't I? So what we're actually gonna do is the elimination method known as the addition method and just combine the two. Because if I do that, I can eliminate the y's. That's why it's called elimination method. So I have 2x, I have 0 y's, and it equals 7. So I would divide by 2, and x equals 7/2. Now the elimination method or addition method, the books will sometimes call it, I can multiply one of those equations by any non-zero number if I wanted to be able to eliminate two things. We will use elimination method in the next process that we're going to do. That's solely what we are going to do over and over and over again. So now we know x, how can we find y?
But putting your X in it, that's all.
Not 0 for x, we have x. X is 7/2. So we can put it in the top equation or the bottom equation. Which one would you like to put it in? Top. Okay, so I have 7 over 2 plus 2y equals 3. Now we're going to have to deal with fractions, such as life. You either have to know how to deal with fractions and just do it, or know how to clear fractions so you don't have to work with them till the end. Okay? Does anyone here know how to clear a fraction so you don't have to work with it till the end? Okay, so I'm going to show you both ways, I guess. How would I solve this equation?
Subtract 7 over 2 from both
Subtract
sides.
7 over 2 from both sides. So 3 has to have a common denominator, yes? So it would be
6 over 2.
6 over 2 minus 7 over 2 would be negative 1 over 2. And then I have to divide by 2 or multiplying by a half. Yes, same thing. Multiply by a half. So y would be what?
Y would be negative 1 over 4.
Because 1 times 1 is 1, so negative 1 over 2 times 2 is 4. Okay? So And I always say if you don't like fractions, you need to learn to get rid of them. Looking back up here, if I wanted to get rid of the 2 in the denominator, what would I need to multiply it all by to get rid of it? 2. Yes? But I have to multiply every single thing there by 2. So if I multiplied it all by 2, I would have 7 plus 4y equals 6, yes?
Yeah.
Subtract 7, so 4y equals negative 1, and divide by 4, so y would still equal what? Negative 1/4. So if you don't like fractions, you need to learn how to get rid of them. But what if I had a 2 and a 3 in the denominator somewhere? I wouldn't multiply by 2, I'd multiply by what? 6. All you're doing is getting common denominators first, then second. Now, it's nice, it's not that bad when the numbers are small. But what if I have big numbers? Would it be easier just to deal with the fractions?
Yeah.
Okay. So I found x and I found y, and I need to write my answer as an ordered pair because this is where the 2 graphs what? Intersect. So they intersect at an x and a y, don't they? So here's your x, here's your y. So at that point, both of those equations are true. Now we all know we check ourselves every single time it's possible. So when we check this, we would have to plug it into both equations and it would have to come out true to be true. Okay? And I said that rather sarcastically because I know you don't, right? But could you if you really wanted to? Yes. Okay. Questions before we go on to the next one? Okay, so I have 2x plus y equals negative 1, 5y minus 6x equals 7.
So,
So-
combine like terms.
There's no like terms.
Oh, it's combined.
Well, first of all, what do you notice about how it's written? Is it lined up nice?
No.
No, it's not lined up nice. And I can't do elimination unless they're completely lined up.
Yeah.
But are my y's or x's going to eliminate nice and easily
Yeah.
Once you get them there.
once you get in there?
I don't know. Find out.
How do you switch?
So I have 2x plus y equals negative 1 and negative 6x plus 5y equals 7. So could I just combine them really nicely?
The way you're saying it makes me think no.
Well, can I?
Yeah.
And will I eliminate anything?
Maybe.
Don't eliminate things.
No.
I won't eliminate anything,
Well, you'll like.
but I need to either eliminate or do substitution. And substitution is solving for a variable and plugging it into the other one. Could I multiply the first equation by something to eliminate? I'm saying first because I got smaller numbers in the first. Everyone see that? Okay. So could I multiply by the first equation by something to get rid of x or y?
Probably.
You said 3.
Yeah.
Why?
Because 2x times 3 would be 6x, and that would take out x.
Right. If I multiply the first equation by 3, I would have 6x plus 3y minus 3, and the positive 6x and the negative 6x would zero out. Okay. So we're going to multiply this whole thing by 3, and I'm just going to write it underneath. I shouldn't do that, but I'm going to. So now I have these equations right here, and I just combine them
Like, why did you?
because I multiplied this all by 3.
Why?
Because he saw that if I multiplied 2 by 3, I had a positive 6, and there's a negative 6. So that would zero the x's out,
Oh.
and you could solve for y and then go back.
Okay. Yeah.
Okay, so then I get 0, I get 8y equals 4. So y equals what?
No.
Half?
Yeah. There is a 2 in it.
You wish it was 2. And then how do I find x?
Put half in for y.
Put half in for y. You want to put it into the first equation or the second equation? first. Okay, so 2x plus 1/2 equals -1. So 2x equals -3/2. Did I do that right?
Yeah.
Because what is 1?
One is
One is,
two halves.
one, 2/2.
2/2. So then subtract another half is -3/2, right?
Yeah.
Some of that we should be able to do without writing it all out, shouldn't we?
Yeah.
Okay, now what?
And divide by negative.
Take it times the half.
Divide by
Times, divide by 2, or multiplying by 1/2. So x equals -3/4. Now, our answer then is -3/4, comma 1/2. Now I want to do it another way.
How are you getting the 2 and the 1/2?
Because
If I divide, I have, how did I get that 2?
No.
This?
Yeah.
Well, I'd have to divide by 2.
Okay.
And dividing by 2 is the same as multiplying by 1/2. And I'm doing that because I have a fraction on the other side. So I'd have to multiply by the reciprocal anyway. Dividing by 2, division is the same thing as multiplying by the reciprocal. So I'm going to do it, and I want to show you another way we could have done this. Do you see the first equation has just y and it has a coefficient of 1? Could I solve for y very easily? Just by subtracting over the 2x, couldn't I? So I would have y equals -1 minus 2x. If I have y equals -1 minus 2x, could I substitute it into the second equation? So I had 5 times y, but we said y equaled -1 minus 2x minus 6x equals 7. Distribute my 5. So I have -5 minus 10x minus 6x equals 7.
So
Add 5. Combine like terms. So -16x equals 12. Divide by -16. And I get x equals -3/4.
whoa.
Is that what we got? Yes.
Got it.
Okay. Now, once I have x, I can plug it back in and find what? Y. So plug it right in here. So I
Wait,
have,
okay, so on the board you have y of -1, -2. Is that supposed to be fraction?
I just took this equation right here and subtracted over 2x. I got that. I solved this equation right here for y. Okay. Did everyone see how I did that? I just subtracted over 2x. If I gave you 2x plus y minus 1 and said solve for y, you wouldn't tell me it was that?
Nope.
What would you tell me it was?
I'd be like, I can't solve this.
You can't solve 2x plus y.
I mean, you could.
No,
Yes.
you.
Still don't understand
No.
how you got the -2x.
Because it's
I'm just so confused because are you taking -1 minus 2x?
Yes.
Okay.
I don't. (2x plus y equals -1). How would you solve that for y? I want it y equals.
subtract 2x.
You would subtract 2x to the other side, correct?
Yeah.
So is y equals -1 minus 2x. Yes?
Yeah. That makes a lot more sense when you see it.
Okay.
Not a verbal learning.
So, didn't think I was teaching that, solving this equation should have been learned a long time ago, correct?
I mean,
Okay,
should've.
so no, I will show things, but I need to know more than I don't understand. Okay, I can't, because I'm sitting up here wondering how to show it to you, because I can't fix, I don't understand. I need specifics what you don't understand, is what I'm trying to say. Okay, so now I do what with this x?
Put it in.
right there. So I have -1 minus 2 times x. So the 2 goes into 4 twice. Negative and a negative is a what?
Positive.
Positive. So I have plus 3 halves. So this 1 is -2/2, right? So I get 1/2. Is
Yeah.
that what I got up there?
Yeah.
Yes.
Okay, chief.
I am not gonna make you do either one. We are going to learn a new process in its elimination. So working on your elimination may be what you wanna do today, but I'm not going to make you do either one. Does that make sense? We are going to work on this tomorrow as well. But I wanted to show you by both methods, you get the same answer. I think the elimination is a pretty much cleaner than the substitution, but that's my personal preference. Am I good?
No.
If we are slow note takers, you might want to leave space and go rewatch videos to finish notes. How much left do you have? You stop.
Yeah.
Okay, 3x plus 2y equals 5, 6x plus 4y equals 3.
Well, they're halves of the things.
Okay,
Yeah.
so elimination might be the way we want to go, right?
Yes.
Okay, so when I do elimination, I typically look at the smaller one to see what I can do to get to the next one, but I could look at the second one too. That's yours is towards what we're doing next.
Well,
We could multiply the top one by -2 or the bottom one by -1/2.
top one by two.
The top one by -2. Why does it have to be a negative, guys?
Because to eliminate it, they have to be.
Right, to eliminate it, it has to be opposite signs, correct? You have to have 1 plus, 1 minus.
Yeah.
Okay, so we're gonna multiply the whole thing by -2. And when I mean the whole thing, I mean the whole thing. Every single term in that first row has to be multiplied by -2.
Okay.
So I have -6 minus 4y equals -10, and 6x plus 4y equals 3. Combine them and solve. What's your left equal? 0, correct?
Yeah, they
I
both.
thought you just said the whole
No.
term.
What?
Every term of the first one.
Every term of the first one equals what?
Negative
-7.
7.
Can 0 equal -7?
No.
No.
There.
So no solution.
Cool one, dog.
Now, we all hope that everyone is no solution, but guess what?
I'm not gonna do it.
No.
Actually, you gotta get one right at least.
Yeah, if you write no solution on everything, then you gotta show me why, so,
Because I said so.
oh, probably is not gonna cut it. Now, what would have happened if I would have taken negative half of the other one?
You would have 3x plus 2y, and then.
So if I did negative half, so I would have negative 3x
Minus 2y.
minus 2y
Equals
negative
3 over 2.
3 over 2. Well, I still would have got 0, yes.
Yeah, and then that would have been.
And this is, what's 5?
So,
Be able to do this. What's
so it'd
5?
be 15 over 15.
How about 10 over 2?
I was far ahead of that.
So 15 over 2. Does 0 equal 15 over 2?
No,
No. So you still get what?
no solution.
No solution.
I like that.
And I could have solved one of those for the other one and substituted in like I did the other problem. Guess what? I'd still get for an answer.
No solution.
No solution. It would have taken you a little longer.
So work on the next.
Yep, I'd like you to try the next one on your own.
Good lined up.
They are lined up, yes.
Does it matter which way we do it?
Nope. You better get the same answer.
Does it have to be divided?
No, you can multiply.
I'm saying, does it have to be divided and multiplied? Or can it be like subtract and add?
Oh, to change it, you have to multiply. To change a row, it has to be multiplication.
Or division? Or just?
Well, it's multiplication by a fraction.
Oh,
We don't say, in this process we're going towards, it's actually called Gaussian elimination, but they don't say those words. It's only, you can add, subtract rows, you combine rows, but you change a row through multiplication. And that's, are you all doing elimination?
Yeah, I think that's what I just did.
That's
Yeah,
okay.
I think so.
Yeah, I think I did. I think that I multiplied the top one by negative.
Okay, did everyone multiply the top equation by negative 3?
I sure did.
Yes.
I did not.
What did you multiply the bottom one by 2?
No.
Oh.
I don't get where you're
I
getting
didn't
the
get-
numbers to multiply.
Okay, I'm eliminating either an X or a Y.
Oh,
Yeah.
Okay, so it doesn't, you have to pick, are you gonna eliminate X or Y?
I eliminated it.
Okay, that's, you have to pick. So what do you wanna pick, X or, eliminate X or Y?
Do X.
I eliminated
X. So if you're gonna eliminate X, this is a 3 and that's a 1. So we need one of them to be positive, one to be negative, and they need to be the same thing. So multiplying the top equation by negative 3 would accomplish that, correct?
Yes.
Now, could I also multiply the bottom equation by 2?
Yes.
And it wouldn't have to be a negative because it's already a negative Y. Those are things you just think about. So if you multiply by 3, negative 3, you're multiplying the whole thing.
Negative 3 X minus. So it would be X minus.
So your X's are gone. You're 0. So now I have 7Y equals 7.
That's exactly what I got.
So Y is what?
Negative 1.
Okay, so the Y on the second equation, that stands for 1, right? So
Yes.
Okay.
Did anyone multiply the second equation by 2?
The second equation by 2, I did not. And I'm everybody in this classroom, so.
No, you're not.
Are you sure?
No.
Hey.
I'm pretty sure.
So that's a lot. negative 1
So-
for X.
Negative 1 for Y in either equation.
Let's do the bottom.
The bottom one?
Because it would be plus 1.
3x minus 1 plus 1, or minus a negative. So it would be 3x equals negative 6, and x equals negative 2. Now, if you need to stop and process that in a minute, that's fine. But those are basic operations that I hope you'll be able to fill in the blank. What did I do to go to the first to the second?
What do you do to go?
What did I do to go from here to here?
You added
There you
Wait,
You added 1.
subtracted
we're
one
combined
from
for like.
I subtracted 1 from both sides. What did I do to go from here to here?
How did you get the
You
plus
just
one?
divided by 3.
Y is a negative 1.
because negative.
Because a negative 1 and a negative y is a positive 1.
Divide by 3 for the second one.
Yes. What I'm trying to do is train our brain not to have to write down every little step, because we're gonna get lost in every little step when we can just do it, right? Do you all know a negative times a negative is a positive?
Yeah.
So
Yes.
it would be negative
So if I have
2.
a negative, negative 1, it is a positive 1.
Yeah.
So what do I have to do with mine?
Put it negative
Negative 2, negative 1. I got it wrong.
What'd you do?
So, I didn't multiply negative 3 by negative 4. So I kind of
Okay.
kept it as 4, and I got 1 over 7. I was trying to do
Yep.
it.
Yep, the whole thing is we've got to make sure what we're doing is we're not changing the equation. We're multiplying it by a scalar, because I could factor out 2 out of an equation, can't I?
Yeah.
And get the same zeros. So that's just a scalar. I can multiply anything I want to an equation as long as I do it through the whole thing, and it doesn't actually change the equation. It just multiplies it by a scalar. I was hoping somebody multiplied the bottom by 2.
No. I mean, I could.
If you multiply the bottom by 2, you get what? 6, 7x equals negative 14, and which gives you negative 2 for x. Okay, am I good?
No. But I like my way better.
Okay. Okay. Malcolm earns $20 per hour mowing lawns, $10 per hour walking a dog. His goal is to earn at least $200 each week, but he can work a maximum of only 20 hours a week, and he must walk his neighbor's dog for at least 5 hours a week. How many hours should Malcolm work at each job in order to meet his goal? So we need to assign some variables. What do you want to assign for mowing, x or y? X. Okay, so x, y. Okay, so I need to write some equations.
Okay. So.
So do I just want to talk about money first?
Yeah.
Okay. So we're gonna have at least $200. So could I make more?
Yeah.
Yes. So my equation could be bigger, right? How am I gonna make that $200?
Mowing and
Mowing and walking a dog. How much do I get paid for mowing? 20. So 20x, right?
Yeah.
How much do I get paid for walking a dog? 10. Okay, so that's one scenario, right?
Yeah.
Okay. I took care of it.
Now hours.
Now hours. So I can't work more than what?
20 hours.
20. So 20. And what's my inequality there?
Less than or equal to.
Equal to.
Can I work less than 20?
Yeah.
Yeah.
Less than or equal to.
No.
Greater
Greater than or equal to. Because my equation can't be bigger than 20.
Okay. Yes.
Okay? So then what am I doing to get the 20? Mowing or walking the dog. So just x plus y?
Yes. Sure.
Well, that would be the same x's for up here, wouldn't it?
Yes.
Yeah, because they would
Divided by
multiply
10.
times the money.
Yeah.
Okay. So the last one I have to take care of is I have to walk a neighbor's dog at least 5 hours a week.
Okay, so we'll be 5 Y.
It'd be 5 and Y. Can I walk it more than 5 hours a week?
Yeah.
Can I walk it less than 5 hours a week?
No.
So what's my inequality? 5
Less.
is
Less than or
less
equal
than or equal to 5.
Dang it.
So what? So there is,
A problem.
okay? And these are inequalities, right? So we know inequalities can be solved by like intervals of numbers, not just a number, correct? So this one we're going to have to graph. Okay, so, and I'm only going to draw the first quadrant because I can't make negative numbers and I can't walk negative hours and things like that, right?
Yeah.
So I personally do not want to solve this for y equals mx plus b and plot the y-intercept and then count the slope. Anybody else?
No.
How about we just find the x and y-intercepts and connect them? Would that work?
Yeah.
Okay. How do I find x-intercepts? That's down here. What are we going to go by, 2s?
Yeah.
No, we're not going to go by 5s.
Why?
Let's go with 87 and a half.
Okay. So if I find an x-intercept, what is my y every single time?
0.
0. Okay, so we'll do this one in blue. Okay, so if I plug a 0 in for y, what's my x?
X is 10.
10. Dividing by 20, yes?
Yeah.
X is 10. 2, 4, 6, 8, 10. Probably should put a 2 there so we don't forget, right? Okay, so then if I want my y-intercept, what is my x every single time on a y-intercept? 0. So that zeroes that out. This 0, if I plug a 0 in here, it's gone. The x is gone, right? So you have 200 is less than equal to 10y, so what's y? I hear one person saying 20.
20.
Do you know it's 20?
I'm pretty sure.
If I have 0 x's and I have 20 is less than 10y, how would I solve that algebraic equation?
Divide by 10.
Divide by 10. So 200 divided by 10 is what? 20. 2, 4, 6, 8, 10, 12,
I know we
15, 16. Oh no.
You did
Just add 2 lines in the middle of the.
Yeah. You got room.
I got room.
We won't tell anybody.
Black.
that. Or we can go up a house.
I already did the other one, 10. Okay, so there's 20. So then I just do what?
Straight line, diagonal line.
Straight line, it's linear.
Right.
That's not very straight, but a straight line. Okay, so I gotta do the other one. I'm gonna do it in red. This is blue. I'm gonna do the next one in red. So an x-intercept, what is the y for an x-intercept? 0. So if I plug a 0 into the second equation for y, what's x?
0.
Wait.
20.
20. Because y is gone, correct?
Yes.
Yeah.
Okay, so 20. If I plug in a 0 in for x, what's my y? 20. And I didn't make it big enough again, did I?
No, ma'am.
Don't worry, I had to add to mine.
This one's easier to add. And did I only need is one more?
Yeah.
2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 12, yeah. And then what do I do to those two lines?
Connect them.
Hopefully with a straight line, not curved like mine.
That's what mine looks
Mine's 3-dimensional. Okay, so then I got this one right here. The last one, right?
Yes, ma'am.
What kind of a line is that?
Like,
Thank you, straight. Good job.
Horizontal.
Horizontal at what? 5. 2, 4, 5. Okay. Now, we know that inequalities, again, are like a whole set of numbers, right? So I need to know where all 3 of these equations are true. So, y is greater than 5. So that would be everything above this green line, correct? So it would be everything this way. Okay? Now, we're going backwards. Red. We got to test things on the left and on the right. Just one thing. What's an easy coordinate pair, x, y, on the left?
On the left, 5.
0, 0.
0, 0?
Yeah.
Yeah? If I plug 0, 0 into the second equation, so 0x, 0y, so is 20 greater than 0?
Yeah.
Yeah, is that true?
Yeah.
Okay, but we're going to check over on the other side just to make sure. So this was 20, so how about like 22? Is that on the other side?
Yeah.
Yep. So 22, 0. The y is 0 down here. I could pick some random point in the middle, but why would I want to when I could use 0, right?
Yeah.
So if I put in 22 plus 0 is 22. Is 22 less than 20?
No.
No. So that's not true. So the red one is this way. Everything over here is true for the red, correct?
Yeah.
Okay, now the blue.
It's,
So we can check 0, 0 again.
yeah.
So 0, 0, so that'd be 0.
Yeah.
Is 0 greater than 200? No. So it's not this way.
So it's.
So it better be this way, right? Okay, so let's, you want to just like 20?
Yeah.
20 is easy to multiply there, right?
Yeah.
Okay, so we're going to do 20, 0. So 20 times 20 is
40.
400. And then, so 0, so 400. Is 400 bigger than 200?
Yeah.
Yes. So the blue equation is all equal over here. So I need where they're all equal together. So that would be where?
Right in there, that triangle.
Right in this,
That bent triangle.
that bent triangle. Shh, it's
Shark
perfectly
fin.
straight.
The shark
It's
fin.
bent.
No, we're just looking at it from a different angle.
Yeah, it's straight over here. I swear.
Okay.
Okay,
It's
So
just the curvature
that-
of the earth.
there is where it would be. So how many hours could I work to make this all happen?
12.
Okay, so our
Which
anywhere
one?
in
Yeah.
between 10 and 20.
Anywhere between 10 and 20, is that going to make it all work?
They should.
As long as I spend 5 of it walking that neighbor's dog, right? Okay.
Yeah.
So.
Well, but it could also.
Okay. So now let's do one where we don't have to write the equations. Would that be nice? This is our last example for today. But this one has how many?
5.
4.
So how many paths am I going to have this time?
4.
4. Okay.
I love math.
I don't know why I'm making so much. You going to go by ones?
Oh man, probably.
Oh,
5,
my.
6, 7,
I'm going by
9, 10,
I'm going
11, 12, 13, 14, 4, 5, 6, 7, 8, 9, 10, 11, 12,
Go by
13,
two.
Okay. So again, guys, I could solve these and put them into slope intercept form and do all that stuff, but I don't have graph paper, do I?
No, ma'am.
If I just do my x and y intercept and connect them, we're going to be good enough.
Okay.
So how do I find an x-intercept?
You put 0 in for y.
You plug 0 in for y. So if I plug 0 into y for the first equation, that means y is gone, so I have 2x is less than 14. So what's x?
Oh,
7.
7.
Yeah, that's nifty.
1, 2, 3, 4, 5, 6, 7.
Buzz out, bell, buzzer.
Now it's the buzzer. It was a phone call.
Oh.
That's why I didn't.
oh.
That's why I let it go. Okay, we're going to get there. Okay, then I need to plug 0 in for x. What's y? 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I plug 0 in for y. On the x-axis, the y is always 0. into the first equation. I plug 0 in for y. 2x equaled 14. Divide by 2 is 7.
So you just plug 0 in.
Yes. 0 for x and y. That's all I'm doing.
Easter is not having.
Okay, so on the
Because-
blue one.
Below you should have like x and x is greater than or equal to 0 and y.
We'll get there. Okay, so we're here. So 0 in for y for the x-axis, right? So that gives me x equals what?
10.
10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then 0 in for x gives me 2y is 10.
Yep.
So y is what?
10.
2y is 10. So what's y?
5.
5. I put that on the wrong one and no one
Yeah, I
caught
was
me.
like,
No
What,
one
what?
caught me.
That's fine.
1,
I
2, 3,
do
4,
not
5,
care.
6, 7, 8, 9, 10.
Oh, come on. Shoot.
And the next one was at 5?
Yeah, just right as the pass. We want to finish this, right?
No.
Yeah.
Yeah.
Okay, it's really, okay. And then we have x is greater than 0, so that's up, yes? That's everything up, yes?
Yeah. My gravity.
Y is bigger than 0, that's what?
Everything
Everything above 0.
And I should not have done that one, I should have done this one in black.
Yay.
No, I like exactly how that looks. That is a beautiful graph.
No. So all the x's are up, all the y's are positive, right?
Yep.
So I need to know this blue, 0, 0, let's check it. 0, 0, is 0 less than 10?
Yes.
Yeah.
Yes.
0 is less.
So this is good over here. Yes?
Yes.
Okay, the black line, which was the red. 0, 0, is 0 less than 14?
Yes.
Yes.
Can I get my
So it's everything,
No.
so it's everything over here, yes? And where they cross is really goofy because I put all this red in here. Is right here.
Okay.
Look at the side over here. Does it have to be straight?
No.
No, it does not have to be a rectangle or a square or anything like that. That's where they all cross is down there.
So then all you're doing is plugging in 0 for x and y separately.
Yes.
Man, now
Math is over.
just play a little careful.
yeah,
Miss On.
I